In this video series, we will take an in-depth look at the different operation modes available on EZmotion's all-in-one servos and how to set them up. These are a few of the common operation modes that are available. In this video, we will focus on torque mode. This mode enables precise regulation of a motor's output torque, allowing for tailored manipulation of the mechanical system's force and motion. To demonstrate torque mode operation, we will use this ball screw actuator along with a compression spring. This actuator converts the motor's rotational motion and torque into a linear motion and linear force. The compression spring on the right serves as a resistance element, exerting a force opposing the motion of the load. Before proceeding, ensure that you are using the correct design file and that your servo motor is communicating with the MotionLAB GUI. While operating the motor in torque control mode, it is crucial to impose a speed limit so that the motor operates within a safe and manageable speed range. First and foremost, let's modify the speed limit in torque control mode. Go to the Parameters tab on the left, then click on the Protection tab. Next, click on the gear icon to show the advanced settings, then click on the Torque Mode tab. Reduce the current loop speed limit to a desired safe speed in RPM units. In this example, the maximum speed is set to 300 RPM. For MMS 742 and MMS 757 motors and drive modules, go to the Parameters tab on the left, then click on the Loop tab. Next, click on the gear icon to show the advanced settings, then reduce the current loop speed limit to a desired safe speed in RPM units. The motor we are using in this video happens to be rated for a 0.32 Nm torque. We can verify this in our tuning parameters settings, which we explored in one of our previous videos. Multiplying the rated current by the torque constant results in the motor's rated torque of 0.32 Nm. Similarly, if the Q-axis current is 2.55 amps, which is 50% of the motor's rated current, then multiplying by the torque constant results in the actual output torque of 0.16 Nm, which is 50% of the motor's rated torque. Next, click on the Motion Test tab located on the left side of the screen. Under Control Mode, use the drop-down arrow to select Torque Mode. To monitor the motor's torque feedback, let's change the axis to show the Q-axis motor current by right-clicking on the Scope window, selecting Curve 1, and then selecting the IQ option. IQ is directly proportional to the motor's output torque. The actual output torque can be calculated by multiplying the motor's IQ by its torque constant. To turn the screw forward, set a negative target torque value. Let's start by setting the target to 15% of the motor's rated torque. Click Update, then enable the motor. We can see the speed is limited to 300 RPM, and the IQ feedback is regulated to 15% of the rated current. However, this amount of torque is not enough to overcome the resistance from the compression spring, so the motor simply holds the position while continuing to apply the target torque. Let's increase the target torque to 50%. We can see the IQ feedback is now regulated to 50%, and the spring has compressed by approximately 0.25 inches. Next, let's increase the target torque to 100%. Once again, we can see the IQ feedback is regulated to 100%, and the spring has compressed by an additional 0.25 inches. To learn more, visit EZmotion.co. Like this video and subscribe to our channel to get the latest on our innovative motion control solutions.